All right, everybody. So this is Unit 2, Day 5. We're going to go over the quadratic formula and the discriminant as well today. The quadratic formula you should have seen back in Algebra 1. If this is looking familiar at all, that is a good sign. So we use the quadratic formula to solve any quadratic equation when it's in standard form. So remember, the number one thing with standard form is it must be equal to zero before you start. So that's always your first step. So first, always make sure it's equal to 0. From there, your a value is that coefficient in front of your x squared. B is the coefficient in front of your x, and C is that constant term when it is in standard form. So from here, then you're just plugging in those A, B, and C values into your quadratic formula and solving from there. So let's look at question example 1. We'll do 1 and 3 together, and then I'll pause the video and you'll do work on your own for questions 2 and 4, and then you can unpause the video and check in with me to see, make sure your work for 2 and 4 was matching up, and then we'll talk about the discriminant. So step 1, I'm equal to 0 in question 1. That's a good start. So kind of off to the side, if it helps you to stay organized, think about our A. What's in front of the x squared? 2. Our b, what's that coefficient in front of the x? 1. And our c, that constant term, is -5. So, thinking about my quadratic formula, x will equal, well, -b. So think about b is 1. So we'll have -1. We have that plus or minus coming into play, thinking about how we talked about that last time from that's what gives us that potential of 2 solutions when we have a quadratic. We have the square root. So inside our square root, we will have our b, which is 1 squared, minus 4 times our a value of 2 times our c value of -5, all over 2 times a, which is 2. So that should be your setup for the quadratic formula for question 1. So from here, it's just a matter of simplifying. So think about your order of operations from here when you're simplifying. Kind of tackle inside that square root first. So we know 1 squared would be 1 minus 4 times 2 times a -5. That would give us 4 times 2 for 8 times a -5, -40. Subtracting a negative would mean this would become plus 40, all over 2 times 2, which is 4. So, think about what we have from here. X will equal -1 plus or minus 1 plus 40 would give us 41, all over 4. So when you're here at this time, you want to think about, can I simplify this at all? So what I mean is, can we simplify inside that square root? Can 41 be simplified at all? No. So actually at this moment here, that is your final answer. You have your 2 solutions. Think about one solution is -1 plus the square root of 41 all over 4. Your other one is -1 minus 41 all over the square root of 4. So we don't want to write those as decimals. We're going to keep them just like this because that is the exact answer. So thinking about what this is saying here, here we have 2. And then these are going to be irrational solutions, right? Those crazy values. So we have 2 irrational. So 2 irrational, but they're real solutions. You could check to make sure that they're two real solutions by plugging them into your calculator, and you should see that it's crossing your x-axis 2 times. So that is example 1. We'll also check out example 3 together, and then you'll try 2 and 4 on your own. So looking at example 3, you should notice from first that it's not equal to 0. So that's our first step, making it equal to 0. So if I move that to a negative 2x squared over, you have a positive 2x squared minus 2x plus 3. So think about first, my A is 2, B is negative 2, and our C is 3. So plugging all that into our quadratic formula. First we have negative B. So if B is negative 2, the opposite, think about making that negative, we make that a positive 2 plus or minus the square root. We'll have B squared, so the negative 2 squared would give us 4. Always note, anytime you're squaring a value, it should be positive. That value there should always be positive. Minus 4 times A is 2 times C is 3 all over 2A, 2 times 2. So let's keep working this out and see what we find. So x will equal 2 plus or minus the square root. I will have 4 minus 4 times 2 would give us 8 times 3 again would give us 24. So 4 minus 24 all over 4. So inside our radical, we would have 2 plus or minus negative 20 all over 4. So what you should be noticing from here is we do have a negative inside our square root. So you're already thinking that you should have those imaginary solutions here. So our answer is not done here, because we want to keep simplifying the square root of negative 20. So let's keep going. So we have x would equal 2 plus or minus. So if I'm simplifying that square root of negative 20, we would have 2I root 5 all over 4. So our one place we tend to always trip up is after this step right here. We can keep reducing. So what you should notice is 2, 2, and 4. You can all simplify those by a factor of 2. I'm not going inside that radical. Not going inside of that, just thinking about the number outside when I'm simplifying. So if I'm dividing all those by a factor of 2, I would have 1 plus or minus 1I, or just I, root 5, all over 2. And that is our solution here. So let's talk about our solution type. We had what type of solution? We had an imaginary solution. So that is going to give us plus or minus, that gives us 2 complex, or remember, that's what it means to be an imaginary number. They're a complex number, so 2 complex solutions. Okay, so I'm going to pause the video now. I'm going to do the workout for problems 2 and 4. So you should also pause the video now, work on problems 2 and 4, and then when you're done with question 2 and 4, unpause the video and then check back in to see if you got the same solutions as me. Alright, so check back in with example 2 in the blue. First, making it equal to 0. putting everything in your quadratic formula, and then you should have found x to equal 7 over 3 and negative 5. So thinking about at this point right here, we were able to take the square root, and that gave us 22. So from there, you're kind of doing those two things to give you your two solutions, negative 8 plus 22, and then divide it all by 6. Negative 8 minus 22, and then divide it all by 6. So that gives us our two solutions. And those two solutions, remember, were two real rational solutions. So think about the difference between question 1. This was irrational. We could not take the square root of 41. That's why number 2 is rational. We can take the square root. Think about rational numbers. Those just mean like your integers and then your fractions. So remember, you could always, if you were unsure, kind of look back at what the graph looks like. Do you cross the x-axis at negative 5? You should. And you cross somewhere that looks like around 7 over 3, you should as well. So checking out example 4, first making it equal to 0, putting everything in your quadratic formula. You should have noticed from this point right here, you were taking the square root of 0. So think about what happens when you're taking the square root of 0. That's just 0. So when you're making your two solutions, it's really only going to give us one solution because 4 plus 0 is the same thing as 4 minus 0. So that'll just give us that one real solution of 1/2. So remember what that looks like graphically. At 1/2, you're just hitting your x-axis one time, right where that vertex is. So that is going to lead us into what we're talking about next, which is the discriminant. So if you are flipping to the next page or following along on paper, so your discriminant is what is underneath the square root. So that idea that b squared minus 4ac. It's what you can find underneath the square root and your quadratic formula. So let's talk about what we noticed from our first page. What did you notice when your discriminant was 0? So think about what's underneath the square root. When it was 0, you only had one real solution. We talked about why that happened. Think about example 3. What happened when your discriminant, think about what was underneath the square root. When it was negative, you had what type of solution? Complex solutions. And then when your discriminant was positive, that's when you're going to have your two real solutions when it's positive. So think about the difference between 1 and 2. If it was a value that I cannot take the square root of, then it's going to be irrational. And then in example 2, if it was a value I could take the square root of, it's going to be real. It's going to be real and rational because that's when you can kind of make those nice numbers. So looking at what the discriminant tells you right here, we just talked about that. So if your discriminant was greater than 0, a positive number, it has two real solutions. That was examples 1 and 2. If your discriminant was equal to 0, it only has one. Don't worry about the double. We'll talk about that more later. It only has one real solution. That was example 4. And if your discriminant was negative, it's going to have two complex solutions. That was like question 3. So find the value of the discriminant and then just tell me what type of solution it would have for each one. So same thing here. you want to set it up in standard form first. So sample 5 is good to go, right? We're already equal to 0. That's check 1. So think about our A is 9, our B is 6, and our C is 1. So I'm not doing the full-on quadratic formula. I'm just doing that B squared, which would be 6 squared minus 4 times A, which is 9, times C, which is 1. So here we'll have 36 minus 36, which gives us 0. So if my discriminant is equal to 0, that tells me I only have one real solution. So let's look at example 6. So first things first, making sure it's equal to 0. So that will look like 9x squared plus 6x minus 4 equals 0. Your A is 9, B is 6, C is negative 4. So same thing, your B squared. So 6 squared minus 4 times A, which is 9, times C, which is negative 4. That would give us 36 plus 144, which equals 180. So we know that is a positive value for your discriminant, which tells you you should have two real solutions. So number 7, set it up in standard form first. So 3x squared minus x plus 3 equals 0. And our A is 3, B is negative 1, our C is 3. So A squared, if it helps you, remember put your parentheses around it when you're squaring a negative. If you tend to accidentally make that negative, minus 4 times A is 3 times C is 3. So this would be 1 minus 36, which would give us a negative 35. So if our discriminant is equal to a negative number, that is going to give us 2 complex, which means imaginary solutions. So that was 5, 6, and 7. So you have 4 more example problems to do. So solve each equation by either factoring, finding the square root, or the quadratic formula. So kind of when your thought process behind this, since we've learned so many different ways to solve, is 1, if you can factor, go ahead, factor first. That's going to be the easiest way to do that. Or actually, first, thinking about square roots. You would do that if you just had only an x squared, or remember if you had that binomial squared. If you have that, I would definitely do that as your first go-to look method. Like looking at example 8, see how you only have an x squared term? I would do that square root method here with question 8. My second thing to look at would be, can I factor it? If you can factor it, that's probably the easiest method to do. So thinking about question 10. Can you factor question 10? Yeah, you can. So go ahead, factor that one. That'll be the easiest way to solve question 10. So going through your process, you can't factor it. What do you do if you can't factor? You are using the quadratic formula. So this is for when you cannot factor. So when you cannot factor, you're using your quadratic formula. So looking at question 9. So you cannot factor that one. Nothing multiplies to give you negative 15 and adds to negative 3. So you're going to work on using that quadratic formula there. So go through these last 4 problems. I'm going to pause the video. I'm going to just write out the work, and then you can unpause it when you're ready to check your work. So after you're done with these notes from here, what you should be doing is one of 2 things. One, you can either work on the textbook homework that's due next time, and 2, you can also work on your review guide that is due next time as well. So those 2 things for next class, you're welcome to work on those for the rest of the time. If you're in second period, make sure you bring your review guide with you on Friday to S2, and also your test if you want to work on test corrections during that S period time as well. So just keep those in mind for next class. So I'll pause the video and you pause it as well so you can check your work.
Alright, so checking back in, so question 8 we already talked about. The easiest way to solve for that would just be using that square root method, because you only have that x squared term, so you should find x equal plus or minus root 2. Question 9, we said, remember, we cannot factor that one, so what do you have to use? The quadratic formula. Our solution there, 3 plus or minus square root of 69 all over 2. Remember, from there, just leaving it just like that. And then our question 10, we can factor that, so we're going to use that easiest method. So factoring, setting your factors equal to 0, you find x equals 16 and negative 2. And question 11, notice you have that binomial squared, so using that square root method again, solving for x, find x equal 4 plus or minus 2i root 3.